Okay, we're continuing on our topic of Earth and space systems. Today we're going to start learning about stars and the life cycle of them. Sorry.
Dear Tim and Moby, how do stars burn out? From Corey. This is one of my favorite topics. Stars change throughout their lives just like we do, only they live for billions of years instead of a few decades. They start out as clouds of gas and dust called stellar nurseries. The force of gravity slowly pulls particles inside these clouds closer together, causing dense clumps to form. If a clump grows large enough, the pressure caused by gravity inside one of these baby protostars begins to generate heat. This heat and pressure build until nuclear fusion reactions begin to take place in the core. Gravity pulls hydrogen atoms together, smashing and fusing them into heavier helium atoms. Nuclear fusion generates an enormous amount of energy, causing the star to ignite. This is the beginning of the longest part of the star's lifetime, or its main sequence. That's where our star, the Sun, is right now. It's about 4.6 billion years old, which means it's a little less than halfway through its 10 billion year long main sequence. Well, what happens to a star after its main sequence depends on its mass. Astronomers actually don't know what happens to low-mass stars, those with less than about half the mass of our Sun. They may actually have a main sequence that lasts more than 1 trillion years. That's longer than the current age of the universe. Mid-sized stars, like our Sun, become white dwarfs. Those are super-dense objects, about as massive as the Sun, but only a fraction as big. They're around the size of the Earth, actually. A couple of things will happen before the Sun turns into a white dwarf, though. The Sun will begin to die when it uses up all the hydrogen in its core. At that point, the Sun will expand, ballooning to many times its current size. Stars in this stage of their life are called red giants because their surfaces cool down to a red glow. Plus, they're really, really big. The Sun will start burning helium at that stage, fusing it into even heavier elements. Eventually, it gets so big that it engulfs the Earth. Oh, don't worry, we'll all be long gone before that happens. It's billions of years away. Anyway, after no more than about 1 billion years as a huge red giant, the Sun will begin to collapse under the pressure of gravity. It'll actually get kind of unstable, expanding and contracting and shedding its outer layers in the process. The remains of those outer layers form a big cloud of gas and dust called a planetary nebula. Nope, they don't have anything to do with planets. They're just called that. But you know, you've probably seen some awesome pictures of planetary nebulas from the Hubble Space Telescope. These are pictures of stars that are at the end stages of their lives. It's kind of like watching what'll happen to our Sun way before it actually does. Anyway, at the center of a planetary nebula is a core of carbon, which, after cooling, finally becomes a white dwarf. Well, that's the route our Sun will take, but it's not the only way a star can die. Stars much bigger than our Sun collapse so quickly that they explode into a supernova, scattering stellar material far and wide. A supernova explosion can last for a month or longer, and during that time it can be as bright as a galaxy with 1 billion stars. The clouds of gas and dust that supernovas spew out are where heavy elements are made, and they lead to the formation of new stars. The core that's left over can go one of two ways, depending on the mass of the original star. If the star is about 10 times as massive as our Sun, the protons and electrons in the core are crushed into neutrons. What you get is a neutron star. Some neutron stars spin rapidly, emitting pulses of radio waves. These are known as pulsars. If, on the other hand, the original star was more than 10 times as massive as the Sun, its supernova core will collapse in on itself. It will keep collapsing until it forms a tiny area of infinite density called a singularity. We call this a black hole, and its gravity is so powerful that nothing within range can escape it. Nope, not even light. And nothing you throw into a black hole will ever come back. We actually have a whole other movie on those, so you should go check it out. Well, time to take the trash out. We take trash out to the corner.